Hello, let's look at this kind of question. So it said determine the mean radius from the given data, a cone angle of 30 degrees and the outside diameter of 550 milliliter and a clutch surface of 81 millimeters. So a conical clutch, uh, before we start, is something like this. This is a conical clutch. Just let me just draw it. Okay, something like this. Just show the inside part. And this is how they have something inside like this. It's like this. And then we have our radius here, outside radius, from this point to this point. This is the outside radius, and this one is the inside radius, and diameter, not the diameter. And this one also, this is the outside diameter, the inside diameter. So we can have our radius from this point to this is the outside radius or external, and this is the internal radius. So when they say calculate them or determine the mean the mean radius, they are looking for RF plus the external radius plus internal radius divided by 2. Here we can say we have the external radius, which is 50 550 divided by 2, because this one is a diameter. So but we don't have the inside one, the internal radius, this one. But what we are given here, we're given what? The cone angle and a clutch surface. So a cone is something like this. You have something like this as the cone. So this angle here, they say it is 30 degrees. So but we don't need the 30 degrees here. We need half of this. We call it a semi cone angle. So we need a semi cone angle. Why do I say we need a semi cone angle? Because the clutch is like this. It's like this, so we need this angle, this small one. So it's something like this now. According to the geometry, if this one is 30, it's 15 degrees, and also this one is 15 degrees. But because we have cut it to half, it's the same thing, but the angle are equal. It's 15 degrees, because here is 15 degrees and also here is 15 degrees. So the whole thing is 30 degrees. So we are looking for something like this. Yeah, we're looking for something like this thing. And we have 15 here, and this is the inner radius, and this one is the outer radius. Now we want this different here, this one. So we want something like this, so that we can get the value of r. So the difference between this point and this point is the 2. So if we have we want this distance from here to here, if this side is 20 and this side from here to here, I mean this side, I mean from this point to this point is 20, and also from this point to that point is 50, right? So if we want this distance, we'll say because it's inner radius, we'll say the outer radius minus the inner radius, because the inner radius is the biggest one from the center to this top. So we can say 50 minus what, 20, so which is 30. So we can use this as a distance from here to here. So we have something like this now. I have something like this. The distance from here to here, it's r outside minus r inside, and then we have 15 degrees here. And then this distance here, they call it a clash surface. This one, it's what, 81 milli, what you call 81 millimeters. So okay, it's like here we are looking for r. The reason we are doing this, because we want to complete this kind of this mean radius. So we don't have r, the smaller r, that's why we are doing there. But we know the difference between here and here is this one. So we can use a Pythagoras theorem to find the rest of the values, because we have hypotenuse and opposite. So according to the ratios, we have something like sine, which is sine theta, which is what we call uh, opposite over hypotenuse. And then we have cos, which is adjacent over hypotenuse. This is a conical clash. It's a cone, something like this. So we don't need the cone, we need the half of the cone, which is a semicone angle. So we have something like tan theta, which is equals to opposite over adjacent. So we have to get the ratio that meet most of the that have less unknown the ratio. This is the ratio, and this one as well, so we have to choose between the three. Which one can we use to get the other value? Because here we have hypotenuse and an opposite and an angle, so we have to check the one that, because here is adjacent, we don't have anything with the adjacent. We have hypotenuse and uh, an opposite this side. So which one? This one have opposite and hypotenuse. This one can fit well, and this one is adjacent over hypotenuse, which we don't have adjacent here. We don't have adjacent here. And then this one we have opposite and adjacent. We don't have adjacent here. We don't have a value for adjacent. So we'll use this equation so to find the value of r. But because we have r, the outside r, we have the outside r, which is diameter, outside diameter divided by 2, which is equals to what do you call 550 divided by 2, you'll get 275 millimeter. So from here we can use the sign, because we are in this position. We have the angle, which is 15, the half of the same angle, which is one we divided by 2, and then we have this distance, which is r minus r r outside minus r, and then we also have 81, the clash surface, the distance from here to here, this point is a clash surface. So we have something like r, which is 275 minus r. We have something like this now, because this one we have it, this one is the unknown that we are looking for. So we have an angle, so we can use sine because this is hypotenuse and this is opposite. So we have less unknown here. Sine theta equals to what you call opposite over hypotenuse. So we can use there is 15 degrees, and then equals to our opposite. What is our opposite? Is this one is 275 minus r, and then divide by hypotenuse. The hypotenuse is what is 81. So we are looking for this one. So what do? We multiply both sides by 81. So what we do on the left, we must also do on the right. This is 81, both sides multiply by so this 81 cancel this 81. So we have something like this. Now 81 multiplied by sine 15 equals to 275 minus r. So we are looking for what? For r, not for 275 minus r. So we'll take the r, let's say we'll take the 275 to the other side. So we have something like 81 multiplied by sine 15 minus 275. Multiplying everything by negative sign, we have something like this. We have something like this now. Now solving for this, for r, we have 275. Calculating this one is 67, and then from here we subtract this 2. We'll have something like 2. We have something 22,32 millimeter. So for here, because we're looking for what, a cone main radius, we have something like r plus r divided by 2. So because we have our r, which is 275 plus 2 comma 32 divided by 2, and then the answer is 386,16 millimeter. So this is the what we call a mean radius. Thank you for watching.